students, good morning. Hope you all studied last class portion. What are the portions we studied in the last class? Are you remember? That is extractive metallurgy of aluminium. Already I told you in this lesson we are going to learn three metals. Okay, what are the metals? Aluminium, copper and iron. In the last class we studied extractive metallurgy of aluminium, right? What is the symbol of aluminium? Al. Color of aluminium is silvery white. Okay, color of aluminium is silvery white. These things last class we studied. And here in this aluminium, extractive metallurgy of aluminium, we studied three ores. From that three ores, what is the chief ore of aluminium? This is important one more question. Don't forget, the chief ore of aluminium is bauxite. Last class we studied these things, right? So today we are going to study extractive metallurgy of copper. Okay, extractive metallurgy of copper. What is the symbol of copper? Cu. Okay, symbol of copper is Cu. Symbol of copper is Cu. And do you know the color of copper? Copper is a reddish brown metal. Okay, copper is a reddish brown metal. And this copper was named as cuprum. Copper was named as cuprum by Romans. Romans give the name cuprum for this copper because this copper was got it from island of Cyprus. Okay, so copper symbol is Cu. This copper was named as cuprum by Romans. Okay, this copper was named as cuprum by Romans. Why they gave this name cuprum means because this copper was got it from island of Cyprus. Have you understood? So next we are going to study important thing, that is ores of copper. Okay, like aluminium, here also we are going to study three ores. So here first ore is copper pyrite. First ore is copper pyrite. Then second ore is ruby copper or cuprite. Ruby copper or cuprite. Then third ore is copper glans. Copper glans. So these are the ores of aluminium. What are the ores of aluminium? Copper pyrite, ruby copper or cuprite. Then third one, copper glans. Next we are going to study the chemical formula of this ores. Okay. So first copper pyrite. Copper pyrite chemical formula. You all know copper symbol is Cu, right? So Cu, copper pyrite, Cu, Fe2. This is copper pyrite formula. Because if you are going to extract one metal in the sense, beginning itself we did not get a pure metal, right? So that metal contains some other impurities or some other element was mixed there. So like that, this copper pyrite, from this copper pyrite we are going to separate the copper. This copper pyrite contains copper, iron and sulfate compounds. Okay, so copper pyrite formula is CuFeS2. Okay. The next ruby copper or cuprite. This formula is Cu2O. Okay, Cu2O. Ruby copper or cuprite formula is Cu2O. The next copper glans. Copper glans formula is Cu2S. Have you understood ores and their formulas? So this copper pyrite contains copper, iron and sulfur. Then ruby copper or cuprite contains copper and oxygen. Okay, mixed there. Then copper glans contains copper and sulfur. Okay, so from these three ores, this copper pyrite is the chief ore of copper. Okay, in aluminium we studied which is the chief ore of aluminium. Bauxite. Okay, don't forget, bauxite is the chief ore of aluminium. In this copper pyrite is the chief ore of copper. Okay, what is copper pyrite formula? CuFeS2. Okay, this is copper pyrite formula. Why it is called as C4 of this? Why this copper pyrite only called as C4 of copper means this copper pyrite only can give 76% of copper. Okay, compare this to this copper pyrite can give more amount of copper. So this copper pyrite is the C4 of copper. It can give nearly 76% of copper. Have you understood? Then next we are going to study extractive metallurgy of copper. That means extraction methods we are going to learn. Okay. So here first extraction method, concentration of ore. First we got ore, right? From the ore only we are going to extract the metals. Concentration of ore. So first this concentration of ore, in this step we are going to crush the ore. Okay, crush means we are make them into powdered form. Okay, so the ore was crushed. Okay, the ore was crushed and it was separated by extract by froth flotation method. Froth flotation method. The ore was crushed and it was separated by which method? Froth flotation method. So froth flotation method means you all know this method, already we learned. So in this method we should take one large tank. This tank is containing oil and water. Okay, oil and water. Then we are, and you have to take some crushed ore also. Oil, water and ore. When we are passing the air, when we are passing the compressed air, this oil can mixed with the water, it can form a froth. That means it can form a foam. Okay, so along with the foam, the lighter particles, the lighter ores was float surface on that tank. Okay, from that method we can separate out that ores and that dense impurities are settled at the bottom of the tank. This is froth flotation method. So in this tank containing oil, water and ore, when we are passed the compressed air, it can agitate. When we are agitating this air, both can form a foam. That means froth. Along with the froth, this impurities, lighter ores or flow surface of that tank. Okay, from that way we can separate that ores. So concentration of ore, first step extraction method, first step concentration of ore. In this method the crushed ore was separated by froth flotation method. First you have to crush the ore and it was separated by which method? Froth flotation method. Then second method, roasting. Roasting you all know, just roasted method, grill method. Okay, so in this roasting what we are going to do? Here we got concentrated ore, right? So that ore was roasted in the presence of air. So that concentrated ore was roasted in the presence of air. Okay, it was roasted in the presence of air. During this roasting process, this moisture, volatile impurities will be removed. Moisture, you all know, watery substance. Then volatile impurities means easily liberated substance. Easily liberated substance means if they contains, for example, see this copper pyrite contains copper, iron, sulfur. The sulfur is a gas. It can be liberated. When it was react with oxygen, it can form sulfur dioxide and it will be liberated. So volatile impurities means what? Easily liberated impurities. Okay, easily liberated substance. So that can be escaped. So this concentrated ore is roasted in the presence of air. The moisture and impurities will be removed. Moisture and volatile impurities will be removed. Okay, remaining we will get some ore. Have you understood the second step? So first step, the ore was crushed and it was separated by which method? Froth flotation method. Then second step, the roasting. Concentrated ore was this concentrated ore is roasted in presence of air, that means in excess of air, we are going to roast this concentrated ore. At that time, this impurities, volatile impurities and moisture will be removed. We will get a ore. Okay. Then next, this roasted ore, roasting process. For example, this copper pyrite. Okay, this copper pyrite is partly converted into sulfates of copper and sulfates of iron. So see the equation. You all know that copper pyrite formula. What is copper pyrite formula? CuFeS2. Okay, CuFeS2. This is concentrated ore. Okay, this concentrated ore roasted with this oxygen. Oxygen formula O2. Okay, what is oxygen formula? O2. So when this copper pyrite roasted with air, roasted with oxygen, it can form the sulfide ore. Okay, this copper can change it into copper sulfate and iron can change it into iron sulfate, and remaining sulfur oxide will be removed here. So see the equation, copper Cus. Okay, copper sulfate can form this Cu and this S. Okay, plus here 2 copper, so here also we can put on 2. You have to balance the equation now. Then next iron, 2 iron is there. Fe means iron. Okay, 2 iron is there. So 2 iron, then 1 S. So iron sulfate. So here listen, copper sulfate, iron sulfate. Okay, plus impurities will be removed. So here the impurity is sulfur dioxide. Okay, SO2. This is a gas, so that we can mention this arrow. Okay, upward arrow means that is gas. Okay, downward arrow means that is precipitate. So have you understood this equation? In roasting process, this concentrated ore, this is concentrated ore, is roasted in the presence of oxygen. It can form sulfide ore. Both are sulfide ores. Okay, copper sulfate and iron sulfate. These are the sulfide ores, and and impurities will be removed. Volatile impurities will be removed. That is sulfur dioxide. Then next process. So 2 process we studied, 2 extraction method we studied, that is concentration of ore and roasting. Okay. Then next we are going to learn smelting process. Smelting already we learned. Smelting process. In the smelting process, what we are going to do? You have to take some roasted ore. Here we got some ore, no? That is called as roasted ore. Okay. So that ore we have to take it here. Okay. So this roasted ore was mixed with coke powder. Roasted ore was mixed with coke powder. What is meant by coke powder? Coke powder means coal powder. Okay, you all know coal, right? So black color coal, you all know that powder. Okay, coke powder means coal powder. It contains lot of carbon compounds. Okay, so this roasted ore was mixed with coke powder and sand. Coke powder and sand, and it is taken in a blast furnace. Blast furnace means that is one type of heating system like an oven. See this diagram, see the picture. This is a blast furnace. So in this blast furnace, we have to take this roasted ore, coke powder and sand. Okay, what are the things we need to take in the blast furnace? Roasted ore. Roasted ore means here in this step we got one product, no? That is a roasted ore. So roasted ore, then coke powder. Coke powder means coal powder and some sand. Okay. When we are given the heating in this blast furnace, it will heat and it will give match. Match is one of the product. This match contains the same product we will get Cu2S plus FeS. Okay, Cu2S plus FeS. The one question maybe they will ask what is the formula of mat? Cu2S and Fe, that is sulfates of copper and iron, that is copper sulfate and iron sulfate. This is called as mat. Have you understood? Remaining some waste product also can form. That product will be, that slag will be removed out. Okay. So in this melting process, this roasted ore is mixed with what are the things? Coke powder and sand. It was taken in a blast furnace. When heating, it can give mat. Mat contains Cu2S and Fes. Okay. The next one. Refine. Sorry, one more step is there. Bessemerization. 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 So bessemerization also like that blast furnace, another one converter. Okay, like that blast furnace only. So in this bessemerization, we should take this mat. Okay. So when we are convert this mat into Bessemer converter, when we are transferred this mat into Bessemer converter, like that blast furnace, this Bessemer converter is another one instrument. Okay, you have to take this mat in a Bessemer converter. When we are giving the heat, this Bessemer converter can give one product that is called as blister copper. Blister copper. Have you understood this bessemerization process? In this bessemerization process, we should take the mat. Okay, we should take this mat in Bessemer converter. So, mat is transferred in Bessemer converter. It is converted into blister copper. Okay, the last step, refine. Refining means purification. Now we got some copper, right? So from this copper pyrite, now we got copper and we have to purify this copper. So this blister copper means it contains 98% of copper, 98% of copper and 2% impurities. Have you understood? In this refining process, this blister copper contains 98% copper and 2% impurities. So, these impurities will be removed by one method, that is electrolytic refining method. Electrolytic refining method. So in this electrolytic refining method, already we studied in this aluminium, extractive metallurgy of aluminium. Two process we studied, that is Hall's process and Bayer's process. That is important question. So study well that one. Okay. So Hall's process and Bayer's process we studied. There we learned this electrolytic refining, right? So the same method here also we are going to use. Okay. So these are the extraction of the copper. Okay, what are the steps? We are using 5 steps we are using in this extraction of copper. That is concentration of ore, then roasting, then smelting, then bessemerization, then refining. Okay, so 5 steps we are using. This concentration of ore, the ore was crushed and it was separated by which method? Fourth flotation method. Then roasting process. In roasting process, the concentrated ore is roasted in the presence of air to form, it can form one ore, it can form roasted ore, and it will be removed that impurities and moistures. Here we studied the equation copper pyrite. Copper pyrite formula CuFeS2. It was reacted with oxygen. In the presence of oxygen, it was roasted, and we will get sulfates of copper and iron. The moisture will, impurities, volatile impurities will be removed. The next smelting process. Here we got roasted ore. This roasted ore was mixed with coke powder and sand. Okay, coke powder and sand, and it is taken in a blast furnace. Okay, what is that? Blast furnace. When heating, it will give one product that is called as mat. Okay, mat contains Cu2s and Fe(S). The next besomerization. In this besomerization process, this mat is transferred in a Bessemer converter. Okay, mat is transferred in a Bessemer converter to obtain blister copper. Then last one, refining. In this refining method, this blister copper contains 98% of copper and 2% impurities. This 2% impurities was removed by which method? Electrolytic refining method. Okay. Then next we are going to study this electrolytic refining method. So already we learned the electrolytic cell contains 3 components, right? What are the components? Cathode, anode and electrolyte. Okay, what are the things it contains? Cathode, anode and electrolyte. So cathode, here cathode is a thin plate of pure copper. Okay, thin plate of pure copper. Just remember that diagram, this electrolytic cell diagram. So electrolytic cell diagram, remember it. You can remember. This is cathode. This is cathode. Okay. So this cathode pure copper. Then anode, that is impure copper. Here some bunches of rod is there. Okay, bunches of graphite rods. So when we are passing current in this electrolytic cell, here we should take a hose. Okay, hose, when we are passing current in this electrolytic cell, pure copper will be settled at this cathode, deposited at the cathode, and impure copper will be settled at the bottom of the rods. Okay, bottom of the anode. So this is electrolytic refining method. And next we are going to study physical properties of copper. Okay, physical properties of copper. Have you understood the extraction methods? Okay, when you are studying this equation, please write and study. Then only you can remember easily. Okay. So next we are going to study physical properties. So physical properties, here the first property is copper is a reddish brown metal. Okay, copper is a reddish brown metal. It is a lustrous metal also. Lustrous means bright metal. Okay, bright metal. It has high density and high melting point. It has high density and melting point. The melting point of copper is 1356 degrees Celsius. Okay, melting point of copper is 1356 and melting point of aluminium is 660. Okay, 660. Have you understood the physical properties? So here the first properties, it is reddish brown metal, lustrous metal, high density metal. Okay, then second one, high density and high melting point. Melting point value 1356. Okay, next we are going to study chemical properties. Chemical properties. So in this chemical properties, first we are going to learn reaction with air and moisture. Reaction with air and moisture. Air and moisture. So when copper reacts with the air, so air contains lot of mixture of gases, right? So oxygen, carbon dioxide. Okay, moisture, that water. Okay. So when copper reacts with the air and the moisture, we will get one green layered copper. Okay, copper carbonate we will get. Green layered copper carbonate. Listen, here 2 copper is there, right? So Cu, then the Cu, then this carbon dioxide combined with one oxygen, okay, to form CO3. Okay, look here, 2 oxygen plus 1, so 3. Copper carbonate, then again one more Cu is there. So Cu, then 2 hydrogen, 2 oxygen. OH twice. This is green layered copper carbonate. Okay, this is the reaction with air and moisture. Then second reaction, reaction with the heat. Here 2 steps are there. Reaction with the heat. So when copper reacts with oxygen, when copper reacts with oxygen, below the temperature 1370 Kelvin, we will get the product copper 2 oxide. We will get copper 2 oxide. This is black in color. Okay, one more question they will ask, copper 2 oxide. What is the color of copper 2 oxide? Black. Okay, then when copper reacts with the oxygen above the temperature 1370 Kelvin, we will get copper Cu, 4 copper is there, so then oxygen. Okay, this is copper 1 oxide. Okay, copper 1 oxide. So we can cancel, we will get 1. So copper 1 oxide. This is red in color. Have you understood? So below the temperature we will get, below this temperature we will get black in color, copper 2 oxide. Above this temperature we will get copper, this is copper 2 oxide, this is copper 1 oxide, that is red in color. The next one, reaction with acid. Reaction with acid. So first copper react with hydrochloric acid. It can form what? It can possible to form copper chloride. Okay, CuCl2. So CuCl2, copper chloride, plus remaining 4 hydrogens. So H2, 4 hydrogen plus oxygen also here. Okay, so water also can form. Okay, 4 hydrogen, then 2 oxygen. So 2 oxygen. Have you understood hydrochloric acid? Then copper react with sulfuric acid. What is sulfuric acid formula? H2SO4. Okay, copper react with sulfuric acid. It can possible to form copper sulfate, CuSO4. So CuSO4 plus, how many hydrogens are there? 4 hydrogens, right? So 4 hydrogen, they are not here too. 4 hydrogen plus oxygen plus sulfur oxide gas also can liberate. Okay, so listen, this copper, this sulfate, SO4, here 2 sulfur and 8 oxygens are there. So that I put 1 sulfur here. Okay, so here only 1 sulfur, here 1 sulfur. Have you understood? It was balanced. Okay, then here 8 oxygen, 4 2s are 8 oxygen, here 4 plus 2, 6 plus 2, 8. Okay, sulfur dioxide is a gas, can be liberated. Then copper react with nitric acid. Copper react with nitric acid. Nitric acid formula HNO3. Okay, HNO3. Copper react with nitric acid. It can form copper nitrate. NO3 twice. NO3 twice. Okay, copper react with nitric acid. It can form CuNO3 twice plus 8 hydrogens. So 4H2O, water plus nitrogen oxide can be liberated. Then when copper react with the chlorine, Cu plus Cl2 gives CuCl2. Copper chloride can form. When it was react with the alkali, it does not attack the copper. Alkali substance, that means base substance, does not attack the copper. Have you understood these chemical properties? So first one, reaction with the air and the moisture. The next one, reaction with the heat. Third one, reaction with acid. Here we studied 3 acids: hydrochloric acid, sulfuric acid, nitric acid. Then fourth one, reaction with the chlorine. Then last, fifth one, reaction with alkalis. Alkalis does not attack the copper. Okay, have you understood? The next class we can study the uses of copper. Okay, thank you.